Okay, so my follow-up talk to my last talk, which was too many slides about too many fishes, is too many slides about rockfishes. And so I'll try to get to the essence of it without deluging you with too many slides and facts, but I can't promise. Hopefully this will be a segue into a discussion of juvenile reproduction, recruitment, and fisheries, which we'll address next week for the 2 days that we meet. So, so I talked about the Atheriniforms, the silver sides over here, and the Beloniforms, which includes the flying fish, the Cyprinodontiforms, which I spelled correctly here, and which include the desert pupfish, and then the Perciform family, which includes things like tule perch, the surf perches, the embryotocids. It also includes a whole range of fishes, including the actual perches, the centrarchids that Andrew spoke about last week, and things like pricklebacks and gunnels and monkey face pricklebacks that you find in tide pools. It's a huge range of fishes. The labriforms, an example of which lives in California, is the California sheep's head with its strange life cycle, its hermaphroditic life cycle. The gobiiforms, this is that's a long jaw mudsucker, I believe. That's a long jaw mudsucker, and it's the gobiiforms are characterized by their pelvic fins, which are arranged in a sort of suction disc that allows them to cling to stones and resist tidal or flows that would knock them off the rocks. The cichliforms, which include the cichlids. Everybody's seen cichlids in aquaria, very important fish in the tropics. Really incredible high diversity, and an example of sympatric speciation in Lake Victoria. Also an example of how landscape management practices and overfishing have led to really the ongoing eradication of this diversity, going from maybe 500 species in one lake in Lake Victoria down to just a few hundred. And such that the catch of fishes is no longer dominated by these natives, but by introduced species, which actually reflects the dynamics here in the San Francisco estuary as well. We mostly catch non-native fishes. We just don't have that kind of off-the-hook diversity. The bleniforms, which are characterized by this fish here, this is a kelpfish. It's a diverse group. That's the one representative here locally. The Plutonectiformes, which I could talk on and on about. It's a really important ground fishery. But I'm not going to discuss it much. We've talked a little bit about how their eyeballs rotate around their heads. Just as long as you know the Plutonectiformes are the flatfishes. And so that's pretty much what we hit last time. So let me jump into the Signathiformes real quick. Signathiformes include seahorses. In California, we don't have seahorses locally, although we do have them down in Baja California. Where I've seen them like wrapped around mangrove roots in the estuaries on the Pacific coast. But more locally, we have bay pipefish, which we found, actually it can be found in abundance with a simple seine across eelgrass or surfgrass. And we saw those down in Half Moon Bay. They have these really cool elongated bodies with these bony rings for armor instead of scales. And they tend to swim with their bodies aligned vertically. So they blend in and look like seaweed. And the females battle for males. The males have the choice in this case because they hold the eggs inside a pouch. The female deposits them in there, they fertilize them and then hold them until they're ready to swim off. And here's the bay pipefish, and you can see that they take on the coloration of the seagrass that they're hanging out in, and they're very interesting, really kind of fabulous fish. And they're surprisingly common in this area. The other order that you should just be aware of are the Scombriforms, which include, also known as the mackerels, which include tunas, yellowtails, mackerels, jacks, that sort of thing. There's an interesting story with the tuna fishery. There's many interesting stories with the tuna fishery that you see in the picture there. That's a $3+ million tuna fish lying on the table, about to be cut up for sushi or sashimi in a Japanese fish market. The issue with tuna is that although widely abundant, such that we have like a canned fishery industry, which began in the 1940s or 1950s, they become scarcer and scarcer. It's still possible to buy tuna fish for cheap, but actually high grade, high quality tuna have become more and more scarce. As they become more and more scarce, the price has gone up. Typically in a reasonable market, the price would have fallen just with inaccessibility, or the price may not have fallen, but inaccessibly would have just, inaccessibility would not have been able to sustain normal prices. In the case of tuna, the price followed the scarcity. If it's something is supply and demand, if it's scarce, the price goes up. And so weird market demands have followed tuna. And I think that this is very much a part of the whole sushi thing has sort of driven a lot of this, the popularity of sushi across the world over the past 20 or 30 years. There's an interesting story packed in there, but maybe we'll get to that in fisheries and maybe we won't. For now, just know that the Scombridae are an important family that include the tuna. And then finally, I just wanted to discuss the, well, not actually, I wish it was finally, almost finally, the Tetraodontiformes. This is the fish group that sort of beamed in from outer space. They're really not related to any other fishes. I mean, they are a spiny fish, an acanthopterygian, but they're 80 million years old probably, which is considerably older than most of the, like the earliest acanthopterygian fishes, which mostly radiated about 60 million years ago at most. So they're very, very old relative to the other spiny finned fishes. They have this weird way of swimming that's characteristic among all of them, even though they have these very strange body plans, from the triggerfish that you see here, which has these really intense beak that they use to break off coral, to the sunfish, the pufferfish, which fills up with water when threatened, and then a boxfish here. The thing that they have in common is they have these bony plates, or the scales are modified into plates or spines or leathery skin. And they have this form of swimming called ostraciform swimming, where the body stays rigid and they just use their little fins to delicately buzz through the water, almost like not quite like a hummingbird, but the same kind of idea where they're very rigid but kind of buzz through. And they have these really highly modified beak-like structures in their mouth that are specialized. And they range from the giant mola mola, which is here in this corner here, which is one of probably the largest member of the order, to very tiny boxfish like this and everything in between. So that's the Tetraodontiformes, a very strange, very unusual, very different family. And then the Gasterosteoformes, which are characterized largely by the stickleback. Stickleback are a very interesting fish with a very wide distribution, a global distribution. They're often associated with estuaries, lakes, or reservoirs. One of the interesting things about them is that they tend to speciate with wild abandon. So here's an interesting case story where sticklebacks were introduced into this reservoir, and they ended up beginning the process of speciation. So one population started spawning in a creek that was pouring into the reservoir, and the other spawned in the shallow waters of the lake. And they differentiated, even though the populations were somewhat panmictic, they differentiated enough to begin the process of developing into slightly different species. It's reflected in the morphology of the fish, and we see it happening in the genomics as well. And UC Davis scientist Peter Wainwright has worked on this, where he's looking at the functional basis of ecological divergence in these sympatric species. Sympatry happens over and over again, especially with this group of fishes, but it's very interesting how there's something that we don't understand about life and the life history of organisms, especially the vertebrates, that sort of pushes them into dividing, to splitting into different groups, because they're exploiting, probably because they're exploiting different habitats, different possibilities for life histories in a way to hedge their bets against a change in environment, a change in circumstances, a change in climate. But what that mechanism is, we don't really know. It's really hard to select, like what's the gene, or what's the gene segment that pushes them to diverge like that. And that's just a big mystery. Did you have a question?
What's the time scale like?
Oh, for this is like over 100 years. Yeah. It's really, really fast in this case, like noticeably, because it's a reservoir. They were introduced to the reservoir, and then people noticed that we had these different populations going on.
So wouldn't that be kind of like a good thing in terms of like climate change, because if they're able to kind of
Yeah. Well, that's the good news. Climate change really sucks for people, but in the end, life does have a way of continuing on, right? And of course, life has sort of offed itself on several occasions. We've been through 5 major extinctions and countless minor extinctions. Presumably, the major extinction that we're in right now will not be the end of life, which is sort of hyperbolic statement that I object to. Not that not that in some ways it's not accurate, but the fact is that this is just another step. It's another step for humans. Like I say, it's a bad thing. For life itself, for the planet, it's just things go on. Philosophically, geologically speaking, not ecologically speaking, right? Has to do with time scales. So that's the fly through of the Acanthopterygians, barring the Scorpeniformes. The Scorpeniformes is the last group that I'll talk about. And then taxonomy is done. And then we have a few weeks to talk about ecology. They're characterized about 1,500 species, a very speciose family, 26, or a very speciose order, 26 families. And they're all characterized by the fact they have this large head, they've got these large round pectoral fins, oftentimes for specialized purposes like sitting on the bottom or otherwise. They have rounded caudal fin. And the key characteristic that all of them share is the suborbital stay. It's a little bone on the back or the underside of their eye. Then this is probably it right there. And that suborbital stay is just a characteristic, a little bump below the eye. And they have spines on their head. And that's a lionfish. So they have very modified spines with poison glands at the bottom. When you press on the spine, the poison comes out. They're sometimes called the male-cheeked fishes, not because you could put them in the mail, because they have mail like a suit of armor. They have these iron, these like armored cheeks of the suborbital stay. And the key families that they include are the sculpins, the caudidae, the hexagramidae, the greenlings, the stonefish, and the rockfishes. And the rockfishes are what I'm going to spend most of the day talking about. But you should know that the caudidae, the sculpins, are very well represented in California. We have prickly sculpins, which live across the river systems of California. And then we also have many, many marine sculpins, which can be found in tide pools, in brackish estuaries. This is one of the largest of the sculpins. It's the cabezon. The cabezon is the largest of the sculpins, and they're common off the coast of California. People love to fish for them. Side note, their eggs are toxic for humans. We don't know why, but they get to be really large, and they're common in Bodega Bay and other places off the coast here. The other family, this is a different family, that was the caudidae, the sculpins. The Synantiidae are the stonefish. And you can see in this, well, actually, I guess you can't really see in this picture. Try that picture. Well, maybe not that picture. Try that picture. All right, there's a stonefish. Those were all stonefishes. They're highly camouflaged. They do a really great job of blending into their background and looking like a rock. And the unfortunate thing about that is that they're extremely venomous. Again, their spines have these poison glands associated with them. And when somebody walks unknowingly along them and steps on them, they can cause like this nasty injection of poison. It can kill you if you go into anaphylactic shock, or just make you swell up and be in a lot of pain. They're basically all mouth, and they sit there and latent as lion weight predators. And when something swims by, they use these massive, highly modified suction jaws. Remember, the ascending and descending process is very well developed in all these fishes. So they open up that jaw and suck in stuff using this magic suction power. That's the stonefish. And then finally, before the rocks fishes, also just know about the hexagramidae. The hexagramidae are also really well represented off the coast here. These are ling cod, which are different than true cods. They're endemic to the Pacific coast here in North America, and mostly up in the north in British Columbia. They're really fecund and they support a really important fishery, especially to Asia. People here get a little freaked out that sometimes their flesh comes out blue, although I think it's kind of exciting. It looks like it would kill you. It looks like antifreeze, but I'm told that it's very good, although somewhat oily. It's a really popular sport fish. That's the hexagramidae. And now, the rockfishes. This is the genus, this is the family Scorpenidae of the Scorpeniformes. Genus Sebastes includes, yes, Mona. Does it come out blue when you cook it? You know, I don't know. I don't know. I don't know that either. It's really weird, isn't it? Yeah, I could try and find out. Yes. Yeah. Have you had it? As are all fish. Probably. Yeah, well, so like salmon, you know, salmon have that red flesh because of the myces that they feed on, the copepods that have that, you know, the carapace color. But is, you know, I don't know what would be blue-green. Yeah, copper compounds. Yeah, but why? Yeah. Have you eaten it? Yeah. How was it? Oily? Oh, interesting. Interesting. Yeah. It's interesting. They're said to be, they have these giant mouths and they're said to be kind of voracious predators. So I'm not sure, you know, I'm not sure what it is they're feeding on that would produce that color. I think it might be something more metabolic, but I really don't know. Thanks for the background. It was really interesting. So the Scorpenidae, the Sebastes, or the rockfish, which we're here to talk about today. But first, we'll talk a little bit about art, because Sebastes, the rockfishes, make beautiful goyutaku. Goyutaku apparently originates from the 1800s. Maybe it's older. It was originally a way of recording your catch by painting the fish and then pressing like rice paper or a very delicate fine paper around the fish and then opening up. And it's just developed into an art form, which the rockfish particularly come to life in. We have a local artist, Chris DeWeese, who was a professor, actually is an extension specialist / professor at over in WFC in Wildlife Fisheries and Conservation Biology. And Chris actually wanted to come out with us to Pewter Creek so that we could do goyutaku of the fishes on the creek along a sort of mural. But we didn't quite get our act together to do that. Maybe in a future year. He wanted to do like a long mural showing the distribution of fishes from pools and riffles, trying to show their different habitats along the range of the creek. But like I say, it didn't happen. But Chris is kind of famous for the stuff he does. He kind of takes it and innovates in unusual ways. Here's a unicorn fish. And if you're interested, you can actually meet him. He works down at the Artery, or volunteers down at the Artery, which is the local artists collective or art, you know, crafts collective. And he wrote a really lovely book called A Life Among Fishes, where he talks about his work as a biologist and also as an artist. So cool thing right here in Davis. That's it. Back into Scorpeniformes. Turns out that these, like the ambiotocids, the surf perches, are very, very young species. So as opposed to the Tetradontiformes, which are like 80 million years old, these are only as old as California, 20 to 30 plus million years ago. These are a species that evolved along with the state, presumably occupying, radiating into the habitats offshore that developed as California uplifted out of the sea and became part of the continental mass. Even more interesting in that are these fishes here. These are almost all sculpins. The sculpins have basically date from only about 1 million years ago, maybe 500,000 years ago in some cases. So it's interesting to me because the sculpins really occupy a lot of intertidal spaces and shallow water spaces. So presumably, while the rockfish moved in to these deep water habitats, the sculpins were able to move into these developing shallow water habitats very, very recently. have capitalized and radiated so that the diversification is really clear, and also the fact that they're very closely related is clear, because if you were in lab and you tried to key out sculpins, you realize that you're really stuck with counting rays and like spines and that sort of thing to differentiate between some of the species. So these are animals that we're talking about today really that have evolved along with California. And California is kind of the epicenter for a lot of their diversity, certainly for sebastes, certainly for surf perches, and also to a lesser degree for sculpins. So they tend to be very deep water fishes, ranging from 3,000 meters to 9,800. Wow, that's random, from meters to feet. So 3,000 meters to 9,800 meters. They're quite deep. They tend to live benthically on substrates. They tend to be they orientate towards the bottom or towards structure, vertical structure. Depending on the species, they'll find different kinds of habitats. And that's probably led to some of the speciation in this group, because they, like these other cases that we've talked about, are another really important example of sympatric, or what one might call sympatric speciation. It could be that the sympatric speciation, or what we call that, is reflective of the fact that we don't really see the differences in the environment, the separation of habitats that they do, and they experience as they experience the environment. So there's about more than 100 species. Most are found here in the Pacific Ocean. There's just a couple in the Atlantic. This is just, you can read this on your own time. Basically, this is just Milton Love, who's kind of the rockfish expert, talking about how embarrassing it is to try to identify rockfishes. He's the expert on rockfishes, and yet he'll find, occasionally a diver or someone will send you a picture, and you just can't figure out what that fish is, either because there's some kind of variation that's built in there, or it's a species that's emerging out into a different subpopulation. But it's always a very humbling thing to be working with these fishes. So it's kind of a funny quote. They're very important fisheries. They have been historically in California, supported valuable fisheries, often called red snapper, rock cod. When I was in college in the 1980s and 90s, I had friends who were going out on the draggers, the trawlers offshore, and making a bunch of money, scooping up rockfish. That fishery has pretty much collapsed by the 2000s, and I'll talk about that a little later. There still remain a sort of important sports fishery, however. More importantly, perhaps, they're a really important component of the California current ecosystem. You might remember I was talking about the California current and the Davidson current, and the sort of latitudinal variation across the state. They're very much mixed up in that, and they're extremely fecund. They're very, very productive. And so they become, not only as adults, but as juveniles, a really important source of food for salmon, for orcas, sharks, seabirds, and the biggest salmon runs often follow big years of rockfish production. The salmon offshore are nailing the baby rockfish. And so there's lots of interesting questions baked into these fishes, both about their evolution and about their ecology. And it's complicated enough where people can spend a lifetime studying this stuff. And I'm going to try and just give you a little hint of some of the questions that surround this species today. The epicenter of rockfish diversity is right off Santa Barbara, much as it was for the surf perches as well. And we talked about the reasons for that because of where the two currents and the California eddy, the California countercurrent mix. There tends to be a gradient of habitats that supports diversity here along this section of the coast. In this picture here, on the left, you can see this is a heat map, and the red shows the highest number of species, and the purple shows the fewest number of species. And you can again see that the high diversity occurs right off Santa Barbara. And that's Santa Barbara is just where Milton Love works. He's a professor there. Maybe the fish love Milton, or maybe Milton loves the fish, but they both end up right around there. And he's kind of a funny guy. I was emailing him last week. I'd never really talked to him before, but I was asking about the distribution of a rockfish, wondering if there was any rockfishes that were just exclusive to California. And he thought not. And he's just kind of a hilarious guy. He's got lots of quips, and he writes these really strange books, like this one. It's very meta. Certainly more than you want to know about the fishes of the Pacific coast. which comes on the heels of everything you wanted to know about the fishes of the Pacific coast. It's like the second edition. Anyway, inside he's got lots of quips and stuff. He's obsessed. He's kind of funny. He's an interesting guy. If you're obsessed with rockfish too, you might want to pick up the book. So as I said, they're a really key component of the California current ecosystem. And here you can see this is a different kind of map on the right here, looking at the current system of California. It shows the sort of gyres that dominate to the north and offshore, and then it shows the California current here. It doesn't really show the Davidson current, which is down here, and the California gyre, which occurs in SoCal, which also make for very complex habitat. But the heat map over here, which actually shows temperatures, these are those anomalies, or, oh, I'm sorry, it's not temperature. I thought that was a temperature map. That's actually a chlorophyll map. So, so we can use a chlorophyll map for this talk. So, so one of the things about California is that because of the currents, the temperature goes through weird gradients. And we talked about that yesterday. But another function of the current system and the upwelling system, upwelling is when you get cold water moving, when you get surface water moving offshore to the west, and it pulls up cold water from the bottom. And that cold water is highly oxygenated, full of nutrients, and fuels massive chlorophyll blooms, which then in turn feed zooplankton, other plankton, invertebrates, fishes, and so on and so forth up the food web. And so what you can see in this heat map of chlorophyll A is a good way of measuring the abundance of phytoplankton. And it's kind of a good food web indicator. And so during periods of upwelling, you can see that you get these blooms of high intensity chlorophyll in the red up along the coast here. And then that diminishes as you move offshore, but you essentially get these plumes of high productivity off the California coast. And those plumes of high productivity are what really fuel the life cycle of rockfish. Like all fishes, they're dependent upon a larval stage. That larval stage has to go up into the water column and drift. And during that period, they have to find food. It's called the critical link. This is a hypothesis by Hjort. Hjort surmised that, or he observed that big blooms of, population explosions tended to occur on the same years where there were plankton blooms. And he said, as soon as larvae, and you may remember this from, we haven't talked a lot about larval development, but we did discuss during salmon, how at some point when they suck up the yolk sac, they use up the yolk sac, they've got to go out and start feeding on plankton. And that moment, that day, that hour, when they've used up their yolk reserves, they have to effectively find food in the water column. And if there's overlap, if they're occurring at a time and place where there's a major plankton bloom, they're going to be successful. And if there isn't, if there's a mismatch in timing, then they're going to crash. And this often can predict, or at least the theory is that this can predict the success of any fishery in a given year. And so that's Hjort's, Hjort hypothesis. And it's called the critical link hypothesis. It's proven notoriously difficult to prove, in part because if you have the overlap and you have fishes grazing on the zooplankton, then your zooplankton populations are really low. And if you have a bad year where there's not a lot of plankton production, then the zooplankton populations are really low. And so when you're trying to do the correlation, it often really buggers it up. So you have to really get into some deeper life history modeling. And so some people have kind of poo-pooed it as a hypothesis, but I think that it explains a lot of the dynamics that we see offshore here, even with Delta smelt, where we clearly have matches and mismatches over their life history. So California current ecosystem, upwelling, zooplankton, phytoplankton production, and currents all heavily factor in to the effectiveness of rockfish, and also were determinants in their evolution. And so key things about rockfish reproduction is that they have internal fertilization. They have extremely high fecundity. They're viviparous. I got it right this time. So they're live bearers, and they give birth to larvae that, so the larvae are reasonably well developed, but when they give birth, they have some yolk reserves, very little. They've got probably a very short window before they actually go out and have to successfully feed themselves. Another interesting aspect about this in terms of ensuring their success is that sperm is stored by females. They can have multiple matings, which some have hypothesized leads them to be able, the female to be able to do retrospective choice of the male partners in terms of deciding which one is most fit. So sperm selectivity from a palette of different donors. That's in the realm of hypothesis. I'm not sure if they have the capability to be able to sort it like that, but it's a cool idea. The embryos are retained for a month to almost 2 months. They get some nutrition from the mother, and then they're off to do their thing. Rockfish live a very long time. And we can do, this is an age length chart here, also known as a von Bertalanffy curve, but von Bertalanffy was an unpleasant person. So why should we remember the name of the unpleasant person when we can just memorialize their reasonably useful finding as a length age curve? So these are length age curves that show the rate of growth of rockfish across their lifespan. And you can see that, well, they stop growing usually within the first 10 to 20 years of their life. And after that, they're sexually mature, essentially. All their growth goes into reproduction, and they can live for a very long time. The interesting thing about this is that during their life, they don't go through a period of senescence where they stop reproducing. They're reproductive all their lives. And in fact, the oldest individuals tend to be the most fertile. And so you can see on this chart here, under fecundity, this shows the fecundity is number of eggs produced, essentially, in the thousands. And so they produce millions of eggs, and they don't taper off throughout the course of their age. You can see that they retain their fecundity across that. And not only that, they retain their reproductive value for most of their life. So, so in the case of each one of these species, they either level out with their reproductive value, or they sort of peak and then drop off just before the end of their life. Humans are very different, right? Humans' reproductive value probably peaks, I'm going to do it exaggerate. So peaks in their 20s, tapers off in their 30s, and then they live a long time. I actually messed it up. Let me erase it. The stylus isn't all that I would have loved it to be. Anyway, so humans, I'm just going to exaggerate the vertical axis here. But humans' pre-productive value, there's no reproduction until they hit about their 20s. They have a short, narrow spike. They're done by their 40s, and then they have no reproductive value at all. That makes no sense on that graph there, but maybe you can see it over here. It's like this. So when they have 10, basically 10 to 40, and they have a spike of reproductive value, and then we live a long time, and we don't reproduce at all. So our reproductive effort is confined to a very narrow window. Rockfishes are totally the opposite. They maintain high productivity throughout their very, very long lives. And so what this was resulted in is that it turns out that as you have bigger fishes, which are referred to, especially the females, because the females are the ones that are controlling fecundity. Sperm is cheap, and sperm donors, they drop off their packet, and the female is the one who really has to imbue the eggs with the characteristics that will make them successful. And so we've identified that big old fat fecund female fishes are the ones that contribute the most to reproduction. And I mentioned this before. So in the graph here, you can see that a 60-centimeter fish is contributing exponentially more propagules, not just eggs, but actually fertility. They're more fertile. And it's for a couple of reasons. The eggs, they're producing more eggs. The eggs are more well provisioned with nutrients, and they're larger, and they have a higher rate of success for that generation than the fishes produced by very young fishes. The fishes, than the larvae produced by very young fishes. And one of the problems with this is that fisheries have traditionally targeted the largest individuals. Why? Because we've had this assumption that larger individuals may be less reproductively fit than younger ones, and also because they're big and because there's less effort applied in catching one large fish rather than 10 small fish. Unfortunately, that undermines the stock recruitment relationship. If you're removing all of the large females from the population, you're making it very vulnerable because it's those big, old, fat, fecund female fish, the boffs or the boffs that are sustaining the population successfully over time. Digging into this whole thing with longevity. So the point of that is to introduce this idea that time and the length of life is extremely important to rockfish in a way that it isn't to other organisms. How do we know this? We know it by looking at otoliths and time check here. This is the thin section of an otolith, and you can see the annuli here, these little stripes, and they can be counted. One way to break this down, this is again in Milton Love's book, and so it's got hilarious little sides here, but this is a fish that was captured in 1987, I guess, and it was 58 years old when caught. And you can see in the center here is when it was born, and then it's got various rings. It was mature maybe 9 or 10 years later. You can see the difference between El Nino and La Nina years. El Nino years tend to be really compressed because they're less successful oftentimes in those years. The current exchange and upwelling system collapses, which leads to periods of scarcity offshore in California. So you can see that in the rings, and then he offers like some random historical things. This fish lived through a spy scandal, James Madison's 200th anniversary, the McCarthy years, Lady Chatterley's lover being banned, and then the first public offering of Microsoft. And Microsoft did it in, I guess. That was it. The Summer of Love is in there too. But anyway, just as a way of stating, this fish is very old. Some rockfishes are over 200 years old, so they would have been almost as old as the United States Constitution themselves. So my point, they live a long time. And northern rockfish in California live longer than southern rockfish for reasons that are not entirely clear. It may have to do with cooler. There's probably a thermal relationship here. The cooler water probably supports some kind of longevity, but I'm not going to dig into that too much. What I really would like to dig into is a little bit more about how current patterns influence the spatial patterns of recruitment. So this is not a rockfish. These are sheephead, so it's a related species. It's in terms of being at least in terms of being a percomorph. So these are histograms that show an index of recruitment at 4 different sites along a southern to northern gradient, 4 different islands, right? And we can use otoliths to sort of back calculate the year that they were born and the year that they settled. And so we can do this to sort of construct an idea of what their year class strength is. That is, years that were successful, years when there was a recruitment and when there wasn't. And so what they found is that in the northernmost island here in San Nicolas Island off Southern California, they found that there was a real variation in terms of year class strength, that is the number of individuals that were recruiting to the population, such that in years down south where there are very successful recruitment off Cabo Thurlo, there was no recruitment at all up north. And so we have these weird periods of lack of recruitment. And so people have been trying to figure out what that is. Is it a temperature related thing? Is it currents? Is it El Nino years? And yes, it's probably all of the above. But let me give you another case history here. there's a couple of different complexes, or we can identify groups of rockfishes as complexes. There's the sort of mid-water complex, which is up here, which are rockfish that hang up in the kelp canopy. And then there's the benthic complex, which are deeper water fishes and hang out down at the bottom. The canopy dwelling fish, the mid-water complex, tends to have very long larval durations, whereas the benthic group tends to have much shorter, maybe half the time, in terms of the amount of water time that they spend out in the pelagic environment before settling down. And what we found is that fishes in the mid-water complex, that is the ones with the long larval duration, do really, really well during, let's look at the bottom graph first, during La Nina years. La Nina years, they do really well. The ones with the very short larval duration do really well during El Nino years. So this is basically looking at, just to explain here on this plot here, looking at relative abundance. And so here's 0 in the middle, which would mean no change. The bar going down to the bottom basically says there's lots of abundance. The fishes are recruiting at a high rate during El Nino years, and they're grouped together on the top in La Nina years. So basically, in El Nino years and La Nina years, we get a real difference in terms of the composition of the species. And that seems to be related to the duration of larvae. Can anyone guess as to what might be driving this based upon what I've said so far? Any wild guesses? La Nina and larval duration. All right, well, La Nina, what happens in the California current during La Nina? And upwelling. Tends to be extremely productive. So there's a lot of food resources in the water. Larvae that are evolved to spend a lot of time are going to need, in the water column as pelagic larvae, are going to need a lot of food resources to sustain them. And so in a season, in a spring, where there's tons of upwelling and it's consistent, they're going to have a really good year. And in an El Nino, which is a warming period, which shuts down the whole upwelling process and really changes a lot of the dynamics of the coast offshore, such that there's lots of starvation in seabirds, in mammals, and fishes have poor recruitment years, it's going to favor animals with a shorter larval duration. And so the thought is that these are responding to availability of food, and there's a different life history with a short larval duration. It's going to do really well during those El Nino periods, those warm periods that don't favor other species. It's a way of ensuring, essentially playing the lottery and using a different life history strategy to be able to ensure success. I'll leave it right there for now. On Monday, we'll come back to the idea and we'll finish up a little bit. We'll move into fisheries. Have a great weekend, everyone. Don't forget to finish up the quiz.